All right, so today what we're going to look at is the trig functions. Okay, there's trig functions. So remember that when you have a function, you have an input and an output. So recall, functions are like machines. For each input, you get exactly one output. Okay? Yeah. All right, so my trig functions that we're going to look at today is we have sine, here's 3. So here's my trig functions. F of x equals sine of x. F of x equals cosine of x. And we have f of x equals tangent of x. Okay? So these are the 3 main trig functions. And there's others, but these are the only 3 we're going to focus on. When you get into pre-calc, there's other functions to look at. So let's do some definitions. I want to define each of these very carefully. Okay? So let's do sine. The sine, okay, S-I-N-E is the full name for that. The sine of a number, A, written as sine of A, is the y coordinate it's the y coordinate of the point you get to on the unit circle by traveling counterclockwise a distance of a units from 1, 0. So that's what we were practicing yesterday, traveling on the unit circle, starting at 1, 0, and then estimating those coordinate points. And that was because we're going to use it for our trig functions. Okay. Now, so this is the sine. The cosine of A, which is cosine A, is the x coordinate. Okay. So same circumstances. I'm not going to rewrite that whole sentence, but when you get to that point, your sine is the y, your cosine is the x. And then tangent is a ratio of those two. It's a fraction. The tangent function, the tangent of A, tan A, is defined as, so tangent of A is the sine of A over cosine of A. It's basically the y over x. So you get the y coordinate over the x coordinate. Okay. Now, using your thumbs up signal, let me know if you have seen this before, if this is familiar. You're like, oh yeah, I remember this. Or I don't remember, but I know I talked about it. I've learned it. Okay. All right. Okay, good. So you may or may not have learned it with this unit circle. Hopefully you did, but we'll see. All right. So let's do some examples. One, find an estimate for A, sine of 3, B, cosine of 3, and C, tangent of 3. So I'm going to plug 3 into my function and get an output. Now, what does it mean to plug 3 into my function? Do you see how uneven that is? Let me be a little more careful here. That's a little bit better, okay? When I plug in 3, what does that mean? Well, let's first fill in stuff on our unit circle, okay? You guys should get in the practice of doing this. This is 1, 0, negative 1, 0, 0, negative 1, and this is 0, 1. So these are the 4 points that are on my circle exactly, okay? There's lots of points that aren't like this. When we get to 3, that point is not on the circle, or it's not an exact point. All right, what else do we know? What is this distance up here in radians? Anybody remember?
Distance? Which one?
Up at the top.
That's just pi over 2.
Pi over 2.
Pi over 2. This one's pi. This is 3 pi over 2, and this one is 2 pi. Okay, good. So you should know that. You have to know that. You also have to have in mind, it's easy if you memorize, it's easier, your life will be easier if you memorize the decimal approximations of these. So pi over 2 is about 1.57. This is about 3.14, and this one is about 4.71. Okay, that's information you have to know. Now, so the first step, walk 3 miles or units or travel or whatever, 3 miles on the unit circle. Okay, so you always start here, 1, 0. And I look ahead and you should see that 3.14 is right at that point. So I'm going to walk and I'm going to stop just before it. So like probably here. Here's 3 miles. Okay. Now, this is an estimated point. So what do we want to estimate X is about?
2.99. Or negative.
Well, it's going to be...
Oh, 0.99.
Yeah, 0.99. So just before -1. And it's really close. Like 3 is very, very close to 3.14. So that X coordinate is very, very close to -1. Now the Y, I don't know, 0.1, 0.2, those are decent estimates, okay? So I have -0.99 and 0.1. Now, let's figure this stuff out. So the sine of 3 then is going to be which number?
Negative.
0.1, okay? It's the Y coordinate. My output of this function is the Y coordinate. Okay, the input is the distance. So I'm putting in my distance, I'm getting out my Y coordinate. Okay, now cosine of 3 is -0.99. And you know what? Let's be really careful here. Do you notice that I use the word estimate? This is all an estimate. If you put sine of 3 in your calculator, you're not going to get exactly 0.1. So let's make sure our notation matches that. And let's use squiggle marks because this means approximately. Okay. Equal is equal. We don't mess with equal. If you're estimating, you squiggle it for approximate. Okay. Now this, the cosine is the output here is my X coordinate. Okay. So that's X. Now tangent is this ratio. Oops, I need my squiggles. It's going to be sine of 3 over cosine of 3, which is approximately 0.1 over -0.99. And that's not particularly going to simplify well. And we're just doing estimates. So you can leave it like that when you do the homework. Usually we don't leave decimals and fractions. If you're really uncomfortable with that and you're good at this, we can move that decimal 2 places in the top and bottom. Basically, you multiply top and bottom by 100. And this is the same as -10/99. Okay, so these are same. But I just want you to get this. It's sine over cosine for right now. That's most important. Any questions?
Wait, Professor N, I'm sorry. This is kind of like at the end. So when you got the -0.99 and the 0.1, that was just a guess estimate, correct?
Yeah. Yep. It's an estimate. You could have 0.2. You could have -0.9. They should be in the ballpark. Like I don't want to see like 0.8 over 0.2. That would be really wrong for this one. So you got to be close.
Okay.
Okay. All right. Okay, let's do this one. So find find sine of, let's do pi over 2, cosine of pi over 2, and tangent of pi over 2. Okay. So again, I draw my circle. Let's fill in what we know. Okay. And I'm going to walk pi over 2 units. So starting here, okay, that's an exact point, right? So where do I arrive? What's the coordinate pair here?
1 for sine.
Well, it's 0, 1, right? So now let's do sine of pi over 2. Yeah, that's going to be 1. Cosine of pi over 2 is what?
0.
0. Okay, it's the x coordinate. Once you have that pair, it's literally you just pull those points right off. Sine is y, cosine is x. All right, last one. Tangent of pi over 2 is sine of pi over 2 over cosine of pi over 2, which is 1 over 0. What number is that? Micah?
Undefined.
It is undefined. That is absolutely correct. You should be really uncomfortable right now because this is not real. This is undefined. So the thing about tangent is since it's a fraction, you have to be careful because sometimes you do tangent and you find that it actually does not exist. So for this one, we would just say tangent of pi over 2, you could just say is undefined. Okay. So here's sine and cosine, and here's tangent. Any questions? All right, let me give you guys 2 to do. So here's example 3 and 4. I want you to find f of x. I want you to find sine of your cosine, tangent when x equals, let's say 5, and x equals -3 pi. So my input in the functions is 5 for the first one, and the input for the functions is -3 pi for the second. Okay. Hey guys, I'll give you like 1 more minute. We're starting the quiz at 11:05. It's a little bit shorter, so I don't think you need the whole 20 minutes. Oh, thank you, Abil. So Abil's telling me he's ready. Yeah, if you're done with both of them, give me a thumbs up so I know. One, two, three, four. Okay. All right. Now for the first one, make sure you walk your distance first, okay? So where should 5 be at approximately? Who would like to tell us? I'll tell you what. Who would like to tell me where to stop? I need you to open your mic up though.
Wouldn't it be between or a little bit past 3 pi over 2?
Yeah, so that's right, Jamil. So like right about here. Okay. So 3 pi over 2 is 4.71, so it's gonna go a little bit past it. So when we estimate this point, I would say 0.4. I don't think that's quite halfway for X. And for Y, I don't know, negative 0.8, something in there. So if you had 0.3, 0.4, 0.5, that's pretty decent. For the Y, negative 0.8, negative 0.9, both those are good. Okay. So that means that sine is negative 0.8. Cosine is the 0.5. And then tangent is going to be the sine over cosine. So it's negative 0.8 over 0.4. And because of the way that does simplify. So, oh, and you know what? Not equals, guys. Squiggles is about, if you divide this, it's negative 2. So either one of these is fine.
I have
Okay.
a question.
Yes.
How do you tell when you're first starting, how do you tell how far along the circle you're supposed to go?
Okay. Think of each of these points as like mile markers. Okay. So when you start here, when you get to here, you've gone 1.57. That's why I write those decimals in there around your track or whatever. Okay.
Okay.
You keep going, when you get here, it's 3.14. Now you've made it to 3.14 miles. Then if you keep going, when you get here, you've gone 4.71, and then just past that will get you to 5. Does that help, Micah?
Yeah, that makes sense. Thank you.
Uh-huh. All right, now for this one, negative 3 pi. Negative means opposite direction. So we're going to go around, here's negative 1 pi, negative 2 pi, negative 3 pi. So negative 3 pi puts you in the same place as pi. So my point here that we're looking at is negative 1, 0. And that is exact. So I'm going to use my equals. So sine is 0, cosine is negative 1, and tangent is sine over cosine, so y over x. Now, what is that number? Is that also undefined?
Some 0.
Yeah, that's just 0. Okay, so you can have 0 over a number, that's just 0. So in this case, tangent 0, cosine is negative 1, sine is 0. Any questions? Okay, I'm going to stop the lecture here.